Hello friends, in this video I'm going to prove, if possible, mm, this equation of an ellipse centered at 0, 0. So this is the equation of an ellipse. X squared over a squared plus y squared over b squared is equal to 1. Now this is centered at 0, 0. Centered at 0, 0. So now this is an ellipse. So this is the center. So this is the major radius. Okay, this OQ is the major radius, and this is your minor radius. Or you can say the major radius is A and the minor radius is B. This length is B and this length is A. Okay. Now the definition of an ellipse is, if you take any point in an ellipse and you join the center, or sorry, join this arbitrary point to any point, sorry, to the focus. This is the definition, that PC1 plus PC2 is constant. Okay, and that constant is 2a. We're going to prove that. Okay, and the other result between, so this is called the focal length. This is the focus. C1 and C2 are the focus, or the foci. So this distance is C and this distance is also C. And we're going to also prove one more result between the relation between A, B, and C. So C is the focal length, A is the major radius, and B is the minor radius. The relationship is C squared, or focal length squared, is A squared minus B squared. We're going to prove this first, and then we're going to prove this. Okay. So what I've done is, I've taken this point P, say to be here. Okay, so P is a point on the ellipse. So using the same definition, can I say, okay, so what is this length? So this is C. We can use Pythagoras theorem. So I've written PC1 using Pythagoras. You can say that is square root of B squared plus C squared, and PC2 is also the same thing. Okay, now if you look at, okay, so let me scroll up. So if you write, what is QC1? QC1 is, can I say QC1 is QO plus OC1. QO plus, this is O, looks like 0. Let me make that bigger. So this is O. So this is Q, I'm talking about QC1 is QO plus OC1. Now QO is nothing but A. So I can say QC1 is A and OC1 is nothing but C. So QC1 is A minus C. Now what is QC2? QC2, this is, I'm talking about this length, okay? This length is OQ, let me rewrite, this is OQ. From OQ, if you take away OC2, you will get QC2. I hope it is clear. I'll rewrite this properly again. Okay, so this is QC2, I'm talking about this length, is QO minus, from QO, if you take away OC2, you'll get that. Now what is QO? That's again A. And what is OC2? That's again C. So I can say QC2 is A minus C. Now Q is also a point on the ellipse. So by definition, QC1 plus QC2 should be a constant. Therefore, by definition, can I say QC1 plus QC2 is equal to, what is QC1? QC1 is A plus C, and what is QC2? That is plus A minus C. So this plus C and minus C gets cancelled. So this is what we have proved, that QC1 plus QC2, QC2, QC1 plus QC2 is equal to 2A. So this is a very important result, that that if Q is taken here, it's very easy to prove that the sum of the distances uh, of any point from the foci is equal to 2A. Okay, so now can we say, but PC1, I'm saying now PC1 plus PC2 should be equal to QC1 plus QC2. But PC1 plus PC2 should be equal to QC1 plus QC2, because P and Q are two different points on the same circle, sorry, on the same ellipse. So by definition, if you add the distances of any point from the ellipse, they have to be the same. So that's what I'm saying. So what is PC1? We say PC1 plus and PC2 are square root of B squared plus C squared. So I can say this is square root of B squared plus C squared plus square root of B squared plus C squared is equal to 2A. Okay, so this is 2 square root of B squared plus C squared is equal to 2A. So you can you can divide both sides by 2. So I can say square root of B squared plus C squared is equal to A. Now if you square both sides, you can say B squared plus C squared is equal to A squared. Okay. Now this implies we're going to write two results. This is very important. C squared is A squared minus B squared. Okay, and you can also make B squared the subject. If you make B squared the subject, that is A squared minus C squared. So we're going to use probably this one of them later on. So these are the important results. What we are saying is, if you take any point on the ellipse and you join them with the two foci and add them, and that will be a constant, which is 2A. Okay, so let us move on to prove this result. Okay, now this is an ellipse. This is, say, your two foci. So this is your A, this is your negative A, this is your B, and this is your negative B. So what are we saying? Now P is an arbitrary point. So I can say, make up this definition, that PC1, I can say PC1 plus PC2 is equal to 2A. Okay. Now what is PC1? PC1, so again this is a right angle triangle. So this is your Y, and this is your the other side. So this is, say, C, this is C, and this is X. So PC1 is easy. PC1 using Pythagoras, I can say that is square root of C plus X squared plus Y squared plus, what is PC2? PC2, this is your Y, and this is from this is uh, how much is this? So I'm talking about so this is your C, from year to year is C, and from C, if you take away X, you can get this much. So I can say, let me show that this is C minus X. This from year to year it's C, and from that, if you're taking away X, you'll get PC2, or this MC2. So I can say this is C minus X squared plus Y squared is equal to 2A. Okay. I'll continue this in the next video.